Hello, I'm Mike McCulloch. Today I'd like to talk to you about the little red dots which have been recently discovered by the James Webb Space Telescope. So this space telescope was launched in 2021 and is 3 times the size of the Hubble, and so it's able to see a lot deeper into space. And what they have seen are very early galaxies which exist about a billion years, I think it's about 0.6 to 0.4 billion years after the supposed start of the cosmos. They're extremely small, about 2% the size of the Milky Way, but it's quite surprising that they have evolved so far back in time. So this is already challenging the standard model. They're red, so long wavelengths, and also they're spinning incredibly fast. So the normal orbital speed of a star in a galaxy is about 200 kilometers per second, but these are spinning at between 1,000 and 2,000 kilometers per second. They're spinning very rapidly. So, of course, what mainstream physics has done in this case is suggest that there's a black hole in the center of them, because a spin of that speed with the amount of mass we can apparently see should mean that they should explode centrifugally, but obviously they don't. So they've had to postulate that each one contains a black hole. There are quite a few of these now, little red dots, about 300 of them, but I don't believe that they have black holes in, because quantized inertia predicts their spin rate. So quantized inertia predicts that the velocity of rotation of a galaxy to the power 4 should be 2 gm c squared over theta, where theta is the cosmic diameter, m is the visible matter in the galaxy, g of course is a gravitational constant, and c is the speed of light. But there are certain things we can do to simplify this equation, because in quantized inertia g is not actually constant. The gravitational constant is not actually constant. It's given by c squared theta over 2 times the mass of the universe. And this comes out very clearly, this formula comes out very clearly if you just, in quantized inertia, you must have enough acceleration within a volume to produce accelerations high enough that the underwaves seen by matter are less than the size of that volume, otherwise they can't be observed. So if you apply this model, you get this formula. You also get another formula that mass is approximately equal to the area of the object. So if you put these two equations in the v to the power 4 equation that I showed earlier, then what you get is that the velocity at the edge of a galaxy should be the speed of light times the 4th root of the mass of its mass divided by the mass of the universe. So that's quite a simple formula. And happily, this predicts for the little red dots a speed of about 1,500 kilometers per second, which is about what is seen. So what this is saying is that quantized inertia predicts that the gravitational constant changes with time, and also the inertial mass reduces with time, such that in the far past the inertial mass was much less, for example. So these little red dots are spinning very rapidly, but the centrifugal forces are not strong enough to explode them, and that is what has been seen by the James Webb Space Telescope. Okay, so I hope you enjoyed this short, and I look forward to seeing you next time. Goodbye.